Okay, Assalamu alaikum students. So today we are going to see IGCSE Physics, October November 2024, paper 4, variant 1. This is a 1 hour 15 minutes ka paper. So let's dive deep into this. A spring is suspended from a clamp. Figure 1.1 shows a pointer attached to the lower end of the spring. ठीक है, एक pointer attached है to the lower end of the spring. A student suspends loads of different weights from the springs and record the reading on the meter rule. ठीक है, आप यहाँ पे डिफरेंट डिफरेंट लोड्स लगाए जा रहे हो और मीटर रूल की रीडिंग को नोट करते जा रहे हो. ठीक है, परफेक्ट है, नथिंग कॉम्प्लिकेटेड है. Figure 1.2 is the reading slash weight graph for the student obtains. Okay. रीडिंग वाई एक्सिस पे, वेट एक्स एक्सिस पे. जितनी जितनी आप वेट लगाते जा रहे हो, जो मीटर रूल पे रीडिंग आ रही है वो आपने वाई एक्सिस पे मेजर कर दी. यूज फिगर 1.1 टू डिटरमाइन द रीडिंग ऑन द मीटर रूल व्हेन नो वेट इज अटैच्ड. जब भी नो वेट अटैच होगा दैट मीन 0 न्यूटन का वेट. सो लेट्स सी 0 न्यूटन के वेट पे आपकी मीटर रूल की क्या रीडिंग. At a weight of 0 Newton, the meter rule की reading is this. Now, how to find this? Can you realize you are going from 40 to 50? You are covering 10 units. In how many boxes? 1, 2, 3, 4, 5. आप 10 units cover कर रहे हो in how many boxes? 5 boxes. One box is equals to how many units? 2 units. ये क्या हो जाएगा बेटा? This will be 43 because ये 2 units हो गए and then you have half a box, so that is 43. जीरो वेट पे या नो वेट पे आपकी रीडिंग आ गई 43 सेंटीमीटर. When a weight of 5.6 Newton is attached to the spring, what will be the reading? अच्छा जी, 5.6 न्यूटन का वेट. 5.6 न्यूटन का वेट कहाँ पे होगा? दिस इज 5 न्यूटन. फ्रॉम 5 to 6 न्यूटन यू आर कवरिंग 1 न्यूटन का वेट इन 10 small boxes. One box will be equal to how many Newton का weight? 0.1 Newton. या one box represents 0.1 newtons. This will be 5.6 Newton. अब 5.6 न्यूटन का अगर आप वेट देखोगे तो ये रहा. Here, what will be the reading on the meter rule? This is 63 सेंटीमीटर. तो जब आपने 5.6 न्यूटन का वेट लगाया तो रीडिंग ऑन द मीटर रूल बिकम 63 सेंटीमीटर. Calculate the extension of the spring when the weight of 5.6 Newton is that simple. जब आपने 5.6 न्यूटन का वेट अटैच किया मीटर रूल की रीडिंग है 63. When there was no weight attached, the reading was 43. What is the extension? 20 centimeters. Simple. ठीक है, 5.6 न्यूटन वाली रीडिंग से नो वेट वाली रीडिंग माइनस कर देंगे. यू विल गेट द extension that is 20 centimeter. Calculate using the value found in A. Calculate the spring constant. अब आपने spring constant K निकालना है. How will you do that? Do we remember this formula? F is equals to K. Yes. F divided by extension is equals to K. Force की वैल्यू क्या है? 5.6. एक्सटेंशन की वैल्यू क्या है बेटे? 20 सेंटीमीटर. अब यहाँ पे आपका अपना बैरोगेटिव है. Whether you want to put length as centimeter or meter, it depends on you. मैं सेंटीमीटर में ही पुट कर देता हूँ 20 सेंटीमीटर. The force was 5.6 Newton. Can you calculate the value of K? Yes, 5.6 divided by 20. This comes out to be 0.28 Newton per centimeter is your spring constant. Easy peasy lemon squeezy. आगे बढ़ते जी, let's move ahead. A mass of 0.5 kg is attached to the spring. Okay. Calculate the weight of the object. How will you calculate the weight of the object? Weight is equal to mg. मास क्या है बेटा? 0.5. वेन एवर द वैल्यू ऑफ जी, जब भी आपको क्वेश्चन में जी की वैल्यू नहीं गिवन, व्हाट विल यू टेक? वेन एवर द क्वेश्चन डजंट प्रोवाइड यू द वैल्यू ऑफ जी, आप जी को 9.8 ms माइनस 2 ले लो, मल्टीप्लाइड बाय 9.8. कर लो क्या आंसर आता है भाई. 0.5 into 9.8, this comes out to be 4.9 Newton as your weight. Easy peasy lemon squeezy. आगे बढ़ते हैं. The object is pulled downward until the tension is equal to this. Okay. The object is released. Calculate the acceleration of the object immediately after it is released. Very, very easy. So the object is attached to the spring like this. बेटा ये आपका object attached हुआ है to the spring. There is a tension in the spring that is equals to what? स्प्रिंग में टेंशन है वो किसके इक्वल है 6.5 न्यूटन. Always remember tension. You can write a key point here. Tension acts away from the object. Tension will always act away from the object. So if you have an object like this, this is attached to a rope, tension will act away from this object. हमेशा याद रखो. Tension always acts away from the object. So here the tension force is acting away from this object. Okay, okay. What is the weight of this object? 4.9. Okay, you have a downward weight of 4.9 Newton. Can you calculate the resultant force, beta? Resultant force निकाल सकते हो? Upward direction में you have 6.5, downward direction में 4.9 है. Resultant force क्या आ जाएगी? 6.5 minus 4.9 resultant force क्या आ जाएगी? 1.6 Newton is your resultant force. Resultant force का क्या फॉर्मूला होता है? Mass into acceleration. Mass into acceleration is equal to 1.6. What was the mass of this object? 0.5. Place 0.5 here. Into acceleration is equal to 1.6. Acceleration की वैल्यू क्या आ जाएगी? 1.6 divided by 0.5. What will your acceleration comes out to be? 1.6 divided by 0.5. This comes out to be 3.2 meters slash second square. Simple. Let's further move ahead. एक blank page आ गया. आगे बढ़ते नहीं. A drag race, a drag car, sorry. A drag car is a racing car that is powered by a rocket engine. Oh, wow, that's good. A drag car accelerates uniformly from rest. Okay, that means you are starting from rest. You are starting from an initial velocity of 0 until it reaches the finishing line. Okay. The engine is then switched off and a parachute opens. Okay. The car decelerates until it stops. Okay. Figure 2.1 shows a drag car decelerating after a race. Okay, so this is a drag car decelerating after a race. Perfect. This drag car has a mass of 1400 kg. Okay, the mass of the drag car is 1400 kg. Perfect. Figure 2.2 is the speed time graph for the car during a race on a straight horizontal track. Okay, so we have a speed time graph. Now, please बच्चों, if you are good students, जब भी आपने speed time graph देखना है, you have to remember these two key points. Gradient of the speed time graph is equals to acceleration. The area under the speed time graph is equals to your distance. Simple. Gradient of a speed time graph is acceleration. Area under the speed time graph is equals to your distance. Simple. Please remember these two key points whenever you are solving any question related to speed time graph. The car reaches a maximum speed of 130 meters per second at a time of 6.5. Let's see. Yeah, the car has reached a speed of what? Maximum speed of 130. Yes, reach की है हमने. And the time is roughly 6.5. That is also correct. Yep. Here. Somewhere here. है ना? Yeah, I think somewhere here. Let me draw it correctly as well. Yep, I think. Yeah. So the car has reached a speed of what? 130 meters per second at a time of 6.5. Okay. Calculate the maximum momentum. What is the formula of momentum? Momentum is equals to mass into velocity. Beta, if you want to calculate the maximum momentum, you will take the maximum velocity. Simple. Maximum momentum is equals to what? What is the mass of the car? कार का मास क्या है 1400. ओके 1400 into the maximum velocity, what which is what 130. Okay, multiply kar do. What does your maximum momentum comes out to be? 1400 into 130. This comes out to be 182,000 Newton per second is your maximum momentum. Easy peasy, lemon squeezy, nothing complicated. Sorry, I have written the units incorrectly. Momentum के units क्या होते हैं? Newton second. Simple. You can also write this correct to two significant figures and in the standard form if you want to. 180,000 Newton second. Now, if you want to write it in a standard form, किस तरह लिखोगे? 1.8 into 10 is the power of 5 Newton second. Any answer is possible. State the feature of figure 2.2 that represents the distance traveled by the car. बेटा फिगर 2.2 का कौन सा फीचर हमें बताता है डिस्टेंस ट्रैवल्ड बाय द कार? Always remember the area under distance time graph is your distance, so you can write it here. You can say area under distance time graph. Distance time graph. Oh, sorry, area under speed time graph. What am I doing here? Area under speed time graph is always equal to the distance. Simple. You have to calculate the distance traveled by the car in the first 6.5 seconds. Okay, you have to calculate the distance traveled by the car in the first 6.5 seconds. Okay. So basically, you have to calculate the area under the graph up till 6.5 seconds. This area. This is what, beta? ये तो एक triangle की तरह दिख रहा है ना? The area under the graph up till 6.5 second looks like what? Looks like a triangle. How will you calculate the area of the triangle? हाँ जी, area of the triangle किस तरह निकालोगे बेटा? बता सकते हो? How will you calculate the area of this triangle? Any geniuses in the chat? How will you calculate the area of this triangle? 1 upon 2 into base into height. What is the base? Base is 6.5. What is the height? Height is 130. This becomes 1, this becomes 65. What does your answer comes out to be? 6.5 into 65. The answer for area 6.5 into 65 comes out to be 422.5 meters. If I round it off till two significant figures, ये क्या हो जाएगा? 420 meters is your distance. You can write it here. 420 meters, easy peasy, lemon squeezy. कुछ भी हमने complicated यहाँ पे नहीं किया, बहुत simple रखी है चीजों को, ठीक है? अब नेक्स्ट सवाल पढ़ते जी. The parachute opens at 6.5 seconds and the car decelerates. Okay. Describe how figure 2.2 shows that after 6.5 seconds the car decelerates. बेटा हमने बताना है कि फिगर 2.2 हमें किस तरह बता रहा है कि आफ्टर 6.5 seconds the car is decelerating. Do you remember the gradient of a speed time graph is equal to acceleration? Can you realize after 6.5 seconds you have a negative gradient? That means you are decelerating. यहाँ पे 6.5 seconds के बाद you have a negative gradient if you draw tangents here to the curve. Let me do this, है ना? बना के दिखा देता हूँ, अच्छा हो जाएगा तुम लोग के लिए. Let's take this and minimize this. Let's keep it here. Can you realize after 6.5 seconds, if you calculate the gradient of this curve, if you start drawing tangents here, oh, if you start drawing tangents here, 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 the gradient of these tangents is negative. That means the car is performing deceleration. So you can say the gradient of the speed time graph, or you can write complete speed time, represents acceleration since gradient Although this is a one marker question, I am giving you a two marker answer since gradient becomes negative after t is equal to 6.5 seconds. The car is decelerated. Simple. Let's look at the second part. The deceleration of the car is not constant. कार की deceleration क्या है? Not constant है. How do you know that? Can you realize after 6.5 seconds you have a curve? 6.5 seconds के बाद आपके पास एक curve है जिसका gradient keeps on changing. Always remember, gradient of curve changes at every point. Changes at every point. बेटा अगर कर्व का ग्रेडियंट हर हर पॉइंट पे चेंज हो रहा है द ग्रेडियंट ऑफ दिस कर्व इज इक्वल टू deceleration. That means deceleration is changing constantly. So you can say the gradient is changing. Hence, deceleration is not constant. ठीक है, hence deceleration is not constant. Simple. Easy peasy lemon squeezy. आगे बढ़ते हैं जी, चलो आगे बढ़ते हैं. Describe the energy transfer that takes place as the car slows down. बेटा जैसे ही car slow down कर रही है, what is happening? The velocity is decreasing. The kinetic energy decreases. There is a loss in kinetic energy. This kinetic energy gets converted into thermal energy. Kinetic energy of the car gets converted into thermal energy. Simple. आगे बढ़ते हैं बेटा. Let's move ahead. Define the moment of a force and describe the effect that it measures. You have to define the moment of a force and you have to describe the effect which it measures. Moment of a force की क्या definition होती है? Moment is the product of force and the perpendicular distance between force and pivot. Between force and pivot. What does the moment measures? बेटा moment क्या measure करता है? Moment measures the turning effect of a force. Moment measures the turning effect of a force. Simple. Let's further move ahead. A large rectangular block of a stone has a square base of what? Side 3.2 meter, 3.4 meters. अच्छा जी यहाँ पे side क्या है? 3.4 meter. Figure 3.1 shows the block at rest on a horizontal surface. The block is of uniform density and the center of gravity G is at its center. अच्छा जी यहाँ पे आपके पास center of gravity है G. State what is meant by center of gravity. What is meant by center of gravity? Point where all the weight of an object seems to be acting. Point where all the weight of an object seems to be acting. Simple. The weight of the block is this. Calculate the moment of the weight of the block about corner x. अच्छा जी, weight of the block आपको given है. ब्लॉक का वेट क्या है भाई? ब्लॉक का वेट क्या है? 1.3 10 raised to the power of 7 Newton. You have to calculate the moment about point x. बेटा the total distance is 3.4 meters. What will be this छोटा सा distance? 3.4 divided by 2, that is 1.7 meters. This Highlighted distance from the pivot to the force is 1.7 meters. Can you calculate the moment? Yep. Moment अभी पढ़ाया था is equals to force into distance. Force क्या है 1.3 into 10 raised to the power of 7. What is the perpendicular distance between the force and the pivot? That is 1.7 meters. Multiply कर दो. 1.7 से multiply कर दो. What does your answer comes out to be? 1.3 10 raised to the power of 7 into 1.7. This comes out to be what? This comes out to be 2.2 into 10 raised to the power of 7 Newton meter is your moment of the force. Simple, easy peasy, lemon squeezy, nothing complicated. State two different conditions required for equilibrium. What are the conditions required for equilibrium? Resultant force should be equal to 0. And resultant moment क्या होना चाहिए? Resultant moment should also be equal to 0. Easy peasy. आगे बढ़ते जी. Describe an experiment to determine the specific heat capacity of aluminum. You may draw a diagram, include in your answer the measurements made and any equations that you use. बेटा ये एक्सपेरिमेंट टू मेजर द स्पेसिफिक हीट कैपेसिटी ऑफ एन ऑब्जेक्ट करा चुका हूं मैं नोट्स में याद है किसी को डू यू रिमेम्बर स्पेसिफिक हीट कैपेसिटी ऑफ एनी ऑब्जेक्ट मेजर करने का एक्सपेरिमेंट में ऑलरेडी करा चुका हूं हम क्या करते थे एक्सपेरिमेंट में याद है कुछ कुछ कोई शहजादा कोई बताना चाहेगा एनी वन एनी जीनियसेस चलो मैं दिखा देता हूँ एक्सपेरिमेंट ही मैं दिखा देता हूँ 1 सेकेंड जस्ट लेट मी शो द एक्सपेरिमेंट 1 सेकेंड यहाँ पे मैं ले आता हूँ एक्सपेरिमेंट को या हियर वी हैव बेटा whenever you have to calculate the specific heat capacity of any solid such as a copper block आप किस तरह से कैलकुलेट करते हो उसको यू टेक द कॉपर ब्लॉक आप कॉपर ब्लॉक लेते हो या एल्युमिनियम ब्लॉक ले लेते हो ये पूरा का पूरा ब्लैक रीजन क्या है कॉपर या फिर एल्युमिनियम ब्लॉक जिसकी भी आपको स्पेसिफिक हीट कैपेसिटी निकालनी है then you insert a thermometer into that block then you insert a heater into that block you apply a voltmeter in parallel to the heater and an ammeter here a battery here and a switch here ठीक है ये आपका कॉपर का ब्लॉक हो गया या एल्युमिनियम का ब्लॉक हो गया फॉर दिस क्वेश्चन you have to draw this diagram ठीक है now what measurements will you take first of all you will note down the initial temperature बेटा आपने initial temperature note down कर लिया ठीक है फिर आपने स्विच को क्लोज किया स्विच को क्लोज करते ही यू स्टार्ट अ स्टॉप वॉच स्विच को क्लोज करते ही यू स्टार्ट अ स्टॉप वॉच then after some time you open the switch you close the stopwatch and you measure the final temperature here आपने स्टॉप वॉच कब स्टार्ट की व्हेन यू क्लोज द स्विच यहाँ पे लिख देता हूँ स्टार्ट द स्टॉप वॉच व्हेन स्विच क्लोज्ड and stop the stopwatch when the switch is open ठीक है जब स्विच ओपन होगा आपने स्टॉप वॉच को स्टॉप कर देना है स्टॉप वॉच को स्टार्ट कब करना है जब आपने स्विच को क्लोज करना you also have to read the voltage की रीडिंग and the current की रीडिंग from voltmeter and ammeter respectively I have written this entire procedure here you can literally copy paste this close the switch measure the current and measure the voltage the power supplied can be calculated using IV okay the energy supplied can be calculated using what power into time ये time कहाँ से आएगा using the stopwatch okay you add that now you also measure the current and voltmeter की reading let's say you have measured the time as 300 seconds you don't have to show the calculation आपने सिर्फ theoretical procedure बता देना you don't have to show the calculation okay you also measure the initial and final temperature you also measure the mass of the block फिर क्या करोगे Q is equals to MC delta temperature वाला फॉर्मूला लगा लो this Q is equals to your energy IVT mass is your mass of the block How will you calculate the change in temperature? Final temperature which you have measured minus the initial temperature. And you calculate the specific heat capacity here. That is the only unknown variable. Simple. तो बेटा इस सवाल में वेयर डू वी हैव दिस क्वेश्चन, आपने इस सवाल में फर्स्ट ऑफ ऑल तो डायग्राम बना देनी. दिस इज कितने मार्क्स का सवाल? लेट मी सी. 4 marks का. लेट मी टेल यू हाउ विल यू गेट दोस 4 marks. First of all, you will draw a diagram in which you will show an aluminum block, you will show a thermometer, you will show the voltmeter, you will show the ammeter, you will show the heater, you will also show the stopwatch. Then you will tell how will the energy be calculated. Energy is equals to current into voltage into time. Current कहाँ से आएगा? Using the ammeter. Voltage कहाँ से आएगा बेटा? Using the voltmeter. Time कहाँ से आएगा? Using the stopwatch. Once you have all of this, which formula will you apply? And which formula will you apply? Q is equals to mc delta T. Energy is equals to your Q. Mass कहाँ से आएगा? Using a beam balance. Mass will be measured using a beam balance. How will you calculate the change in temperature? Final temperature minus initial temperature. How will final and initial temperature be measured? Using a thermometer. Then you can easily calculate the specific heat capacity. Easy peasy, lemon squeezy, nothing complicated here. Perfect. ये निकाल लेना बेटा. इसको कॉपी पेस्ट कर लेना. Whatever you want to do. These are the 4 points. Last आपको ये पॉइंट मिल जाएगा that you apply the formula and calculate the specific heat capacity. Simple. You rearrange this formula. Q divided by m delta T is equals to your specific heat capacity. Last point is on this. An aluminum dish is initially at room temperature. Okay, you have an aluminum dish that is initially at room temperature. Boiling water is poured into the aluminum dish as shown in figure 4.1. ठीक है, boiling water pour हो रहा है into the aluminum dish as shown in figure 4.1. Okay. Explain why after a short time the dish, the water are at the same temperature. बेटा आपने बताना है why after a short time the dish and water are at the same temperature. आप क्या कहोगे? The energy flows from higher temperature to lower temperature. Water loses heat and the dish of aluminum gains heat. है ना? ऐसे ही होगा. You can write here. Energy flows. Yeah, energy gets transferred. Energy. I will have to write it in very small handwriting. Energy flows from. Energy flows from higher temperature to lower temperature. Energy कह दो, heat कह दो, whatever you want to say. Aluminium dish, aluminium, aluminium dish gains heat, and its temperature rises. Okay. However, water loses heat and its temperature falls. लास्ट में आपने क्या बताना है? Why after a short time the dish and water have the same temperature? What will be your last statement? You will say after some time temperature of dish is equals to the temperature of water. Hence, no net heat transfer. Simple. आगे बढ़ते बेटा. Explain in terms of particles why aluminum expands as the boiling water is poured into the dish. Aluminum क्यों expand करता है as boiling water is poured into the dish? You will say the molecules or particles of aluminum gain kinetic energy. As they gain kinetic energy, the separation between the particles of aluminum increases or they move apart. You will say as temperature of aluminum. I am not writing aluminum dash pura pura. I am just writing aluminum increases kinetic energy of molecules. Yeah, kinetic energy of particles. Always remember in physics, we don't use the word of molecules, we use the word of particles. Kinetic energy of particles of aluminum increases, and hence the separation between particles between particles increases. Simple. आगे बढ़ते हैं. The water in the dish evaporates. Explain in terms of water molecules what is meant by evaporation. Evaporation का क्या मतलब होता है? Molecules with greater kinetic energy or higher kinetic energy escape from the surface. Hence, the average kinetic energy of the remaining molecules decreases. Okay? What will you say? You will say molecules या particles कह लो water molecules देखो specify किया हुआ है तो we will use the word of molecules with greater kinetic energy escape the surface of water. Molecules with greater kinetic energy क्या होता है? Molecules with greater kinetic energy escape from the surface of water. Hence the average kinetic energy of water molecules decrease. Hence the temperature decreases. ठीक है. Temperature का पूछा नहीं है, but we will write it just to be over smart. A loudspeaker produces a sound wave in air. The distance between the center of a compression to the center of a neighboring rarefaction is 0.1 मीटर. अच्छा जी, compression से लेकर rarefaction तक distance हमारा क्या है? 0.1 मीटर. Okay. Calculate the wavelength of the sound wave. Okay. बेटा कंप्रेशन से लेकर rarefaction तक आपकी वेवलेंथ क्या होती है? हाफ लैम्डा. तो यू रिमेम्बर कंप्रेशन से कंप्रेशन तक आपकी वेवलेंथ लैम्डा होती है. रेयर फैक्शन से रेयर फैक्शन तक वेवलेंथ इज लैम्डा एज वेल. हाउएवर कंप्रेशन टू रेयर फैक्शन आपकी वेवलेंथ क्या हो जाती है? हाफ लैम्डा. तो हाफ लैम्डा इज इक्वल टू 0.1 meters. What will your wavelength come out to be? Wavelength is equal to 0.2 meters. Write it here. State a typical value of sound in air. You can write anything from 330 meters per second to 350 meters per second. Calculate the frequency of the sound from the loudspeaker. Okay. Let's say यहाँ पे मैं velocity की value consider कर लेता हूँ 340 meters per second, which is in the middle. Okay. You can write anything from 330 to 350. Now you have to calculate the frequency of sound. You will apply V is equals to F lambda. What is my velocity value? 340. What is my wavelength value? 0.2. What will your frequency comes out to be? निकाल लो. 340 divided by 0.2, the frequency comes out to be 1700 hertz. Simple. Explain whether the sound from the loudspeaker is audible to a human with normal hearing. Yes, the sound from the loudspeaker is audible to a normal human being. Why? Because this lies within the audible frequencies. That is of 20 hertz से लेकर 20,000 hertz. This frequency of sound is greater than 20 hertz and less than 20,000 hertz. Hence, this is audible to a normal human being. Okay. So you will say the frequency is greater than 20 hertz and less than 20,000 hertz. Hence, it is audible to a human with normal hearing. Simple. Nothing complicated here. आगे बढ़ते हैं. Let's move ahead. Another loudspeaker produces a sound of wavelength 0.4 meters. Okay. Sound from the loudspeaker reaches a sound absorbing surface with a gap of width 0.8 meters at the center. Figure 5.1 shows the arrangement. Okay, ठीक है. आपका gap क्या है? 0.8. आपकी wavelength क्या है? 0.4 meters. Okay, this will turn out to be very, very important. Explain whether it is possible to detect the sound from the loudspeaker at either point J or either at point K. अच्छा आपने बताना है क्या J पे sound आ रहा है क्या K पे sound आ रहा है. How will you tell that? Now this is a typical case of diffraction. Can you realize the wavelength? Wavelength क्या है? Wavelength is much less compared to the gap size. This is your gap size X. जब भी आपकी वेवलेंथ छोटी होती थी कंपेयर टू द गैप साइज यू हैड लेस अमाउंट ऑफ डिफ्रैक्शन सो योर साउंड विल नॉट रीच point J. However, due to the less amount of diffraction, it will reach point K. यहाँ पे reach कर जाएगा but J पे नहीं reach करेगा. How will you write this answer? You will say since wavelength is much smaller compared to the gap size. Compared to the gap size, little diffraction occurs. Little diffraction occurs. Hence, आप क्या कहोगे? What will you say further? Little diffraction occurs. उसके आगे क्या कहोगे बेटा? Little diffraction occur कर रही है जिसकी वजह से क्या हो रहा है? Hence, no sound or little sound is heard at J. Hence, no sound is heard at J. K पे आएगा साउंड क्या? हाँ जी. Sound will be heard at K. Why? Because a little amount of diffraction do occurs. So you will say since a little diffraction occurs, sound is heard at point K. Simple. आगे बढ़ते हैं बेटा. Let's move ahead. A potential divider is made by connecting a light dependent resistor and a thermistor in series. Figure 6.1 shows the potential divider, a voltmeter, and a direct current power supply connected into a circuit. Okay. The voltmeter measures the potential difference across the LDR. Achari. Define potential difference. What is potential difference की definition? क्या किसी को याद है? What is potential difference की definition? Work done per unit charge in moving a unit charge across an electrical component. ठीक है, ये बात याद है. Work done per unit charge. You can write here. You can say potential difference की definition. You can write here. Work done. Oh, work done per unit charge in moving a unit charge across an electrical component. Simple. इजी पीजी लेमन स्क्वीजी, आगे बढ़ते हैं जी. The electromotive force of the supply is E. Okay. Describe how the potential difference across the thermistor can be determined using the reading on the voltmeter. बेटा हमने potential difference across the thermistor निकालना है. This. How can that be determined using the reading on the voltmeter? The reading on the voltmeter tells you the voltage across the LDR. The EMF of the battery is capital E. If you take the EMF minus the voltage across the LDR, it will give you the voltage across the thermistor. What will you say? क्या कहोगे यहाँ पे? How will you calculate the potential difference across the thermistor? हाँ जी. How will you calculate the potential difference across the thermistor? The potential difference across the thermistor is equals to the EMF minus the reading on the voltmeter. Easy peasy. आगे देखते हैं क्या लिखा हुआ है. The resistance of the LDR decreases and the resistance of the thermistor increases. State what happens to the light intensity incident on the LDR and the temperature of the thermistor. बेटा अगर LDR की resistance decrease हो रही है इसका मतलब क्या है? इसका मतलब ये है light intensity increase हुई होगी. Light intensity might have increased, so you can write it here. And if the resistance of the thermistor is increasing, what might have happened? The temperature might have decreased. तो यहाँ पे लिख लो temperature might have decreased. Explain what happens to the reading on the voltmeter. आपने बताना है reading on the voltmeter को क्या होगा if this actually happens. Okay, so let's move ahead. Now, can you realize the resistance of the LDR is decreasing? That means the voltage across the LDR will decrease. However, the resistance across the thermistor is increasing. The voltage across the thermistor will increase. So the overall reading of the voltmeter will decrease. तो आपने इस आंसर को थोड़ा सा अच्छा करके स्ट्रक्चर करना है. You will say, since the resistance across the LDR decreases, it now is a smaller portion of the total resistance. Beta, resistance of the LDR is now a smaller portion of the total resistance. Hence, the voltage across the LDR is a smaller portion of the total EMF. Hence, the voltmeter reading decreases. इस तरह लिख सकते हो. You can write it like this. So let's write it. You can first of all say what happens to the reading on the voltmeter. The reading of, yeah, the reading on the voltmeter decreases. Why? Why? क्यों होगा ऐसा? Because you will say the resistance of LDR decreases. Hence, it is now a smaller portion of the total resistance of the total resistance. This causes the voltage across LDR to be a smaller portion, of the total EMF, of the total EMF. easy peasy lemon squeezy. इससे ज्यादा और क्या इजी होगा? आगे बढ़ते नहीं. A solid bar is inside a copper solenoid. Figure 7.1 shows the copper solenoid is connected in series with a battery and a variable resistor. Okay. The device shown is an electromagnet. State a suitable material for this bar. You have to state a suitable material for this bar. What could be a suitable material for this bar? Soft iron. Perfect. The right hand of the bar is the south pole. Okay. On figure 7.2 shows the view from above. Okay. On figure 7.2, draw at least 6 magnetic field lines to show the pattern and the direction of the magnetic field surrounding the magnet. This is south, this will be north. क्या होगा? Magnetic field lines will emit from the north, go into the south. it will emit from the north, go into the south. Now you have to draw at least 6 field lines. What can you do? You can make some field lines that are emitting from the north, curling like this. हमें 6 कहिए, हम 8 बना देते हैं. Let's be over efficient, because being over efficient in the examination never ever harms you. Yeah, this will be your pattern. Let's further move ahead. The resistance of the variable resistor increases. अच्छा जी, resistance increase हो रही है. Okay. Explain what happens to the magnetic field surrounding the bar and state how the pattern of the field lines that represent the field changes. Okay. If your resistance is increasing, beta agar iski resistance increase ho rahi hai, what will happen? The current decreases. As the current decreases, what will happen to the magnetic field? Magnetic field weakens. Magnetic field weakens. And what will happen to the magnetic field lines? They will move away from each other. Magnetic field lines away from each other. Your distance between the magnetic field lines will increase. So you will say, as resistance increases, the current in the circuit decreases. As the current in the circuit decreases, क्या होगा? हाँ जी, करंट इन द सर्किट जैसे ही डिक्रीज होगा, क्या होगा बेटा? Yes, the magnetic field strength decreases. The current in the circuit decreases. Hence, the magnetic field strength decreases. और magnetic field strength decrease होगी तो क्या होगा? हाँ जी, as the magnetic field strength decreases, क्या होगा? The magnetic field lines will move away from each other. Hence, the magnetic field lines, magnetic field lines move further apart. Simple. Let's move ahead. A square coil of many turns is placed close to the bar. Figure 7.3 shows the plane of the square coil parallel to the flat circular surface at the right hand end of the bar. Okay, ये square coil है, ये bar के करीब placed है. Okay. The resistance of the variable resistor is alternatively increased and decreased. अगर आप resistance को increase decrease करोगे, what will happen? The current will increase and decrease. If the current increases and decrease, बेटा अगर जो बार के ऊपर करंट आ रहा है वो increase decrease करेगा, what will happen? The magnetic field of bar changes. As the magnetic field of the bar changes, it will cut with the square coil, inducing an EMF between the terminals. Let's write it down. What will you say? You will say the changing resistance causes the current to change. The changing. So let's write down this answer. You will first of all say the changing resistance causes the current in the solenoid to change. This changing current causes a changing magnetic field. This changing current causes a changing magnetic field. This changing magnetic field cuts with the square coil. This changing magnetic field cuts with the square coil, generating an induced EMF. This changing magnetic field. This changing magnetic field cuts with the square coil, with the square coil, generating induced EMF. Simple as that, nothing complicated here. आगे बढ़ते हैं बेटा. The nuclear notation for a radioactive isotope carbon 14 is this: 14 6 carbon. Use the symbol shown in figure 8.1 to draw a diagram to show the number of electrons, neutrons, and protons in a neutral atom of carbon 14 and state how they are arranged. First of all, neutrons and protons बना लेते. Neutrons and protons both are in the nucleus. How many protons do we have? 6. Let's make 6 colorful dots. Sir, आपको कैसे पता चला 6 proton है? Here you can see. Proton number is 6, hence you will have 6 protons in the nucleus. Let's draw them like this. Although they will not be arranged like this, but मैंने ऐसा बना दिया because of the easiness to draw it like this. 14 6 carbon. Can you calculate the number of neutrons? Yes, 14 minus 6, the number of neutrons is 8. Neutrons are empty circles. 1, 2, 3, 4, 5, 6, 7, 8. Okay. How will you draw the electrons? Electrons are in the outer shell. Let's do it. So let's put the 2 electrons in the first outer shell. This is basic chemistry. पहले इलेक्ट्रॉन शेल में 2 इलेक्ट्रॉन्स होते हैं और फिर you can draw the remaining electrons in the last shell. There will be 6 electrons. Why? Because this is a neutral atom. In a neutral atom, the number of protons and electrons are same. If proton is 6, electron will also be 6. Simple. आगे बढ़ते हैं. I think we have done this correctly. Yeah. Describe how the composition of a neutral atom of carbon 14 is different from the composition of a neutral atom of nitrogen 14. Nitrogen 14 looks something like this. Carbon 14 looks something like this. Can you realize nitrogen has one more proton? You can write it. Nitrogen has one more proton. What else? अगर यहाँ पे आप नंबर ऑफ न्यूट्रॉन्स निकालो ऑफ नाइट्रोजन 14 minus 7 7. Number of neutrons निकालो of carbon 14 minus 6, that is it. So you will say carbon has one more neutron. Easy peasy. Let's further move ahead. Carbon 14 decays by beta emission. State the name of particle that is identical to a beta particle electron. Describe the change that takes place in carbon 14 as a beta particle is emitted. क्या change होता है as a beta particle is emitted? And या इस तरह कह लो अब a neutron. Whenever a beta particle is emitted, a neutron gets converted into a proton. Simple. The half-life of carbon 14 is 5,700 years. A very old object of wood contains 1.210 raised to the power of 11 atoms of carbon 14. When it is manufactured, it contained these amount of atoms of carbon. मतलब आपकी initial value ये है, final value ये है. You have to calculate the time that has passed since it was manufactured. किस तरह निकालोगे? Initial value is 9.610 raised to the power of 11. After one half life, after 5,700 years, क्या हो जाएगा? Half हो जाएगा. This will become 4.8 into 10 raised to the power of 11. After one more half life, after 5,700 further years, this will become 2.410 raised to the power of 11. After another half life, 5,700 years, it will become 1.210 raised to the power of 11. तो कितनी हाफ लाइफ स्पैन आउट कर गई बेटा? कितने हाफ लाइफ स्पैन आउट कर गई? 3 हाफ लाइफ स्पैन आउट कर गई. कैन यू कैलकुलेट द टोटल टाइम? 5,700 into 3, this comes out to be 7. Let me write it correctly. 5,700 into 3, इसका आंसर क्या आ जाएगा? 17,100 is according to the convention of IG. Let's put it till two significant figures. 17,000 years is your answer. Let's further move ahead. The Milky Way is the galaxy in which solar system is located. State what is a galaxy. अब आपने galaxy की definition देनी है. Galaxy is a collection of billions of stars. You will say collection of billion of stars. Simple. The Milky Way has a diameter that is approximately 1 lakh light years. State this distance in kilometer. हमने 1 लाख लाइट ईयर्स को किलोमीटर्स में करना है. 1 लाइट ईयर किसके इक्वल होता है? 1 लाइट ईयर is equals to the distance traveled by light in 1 year. Distance is equals to speed into time. Speed क्या होगी लाइट की? 3 into 10 raised to the power of 8. What is the time in 1 year? 365 days. 365 into 24 hours in 1 day, 60 minutes in 1 hour, 60 seconds of 1 minute. Can you calculate the distance that is equals to 1 light year? Yep, 3 into 10 raised to the power of 8. 365 into 24 into 10. No, this comes out to be 9.46. 10 raised to the power of 15. This is 1 light year. This is in meters. ये meters में. You have to calculate for 1 lakh light years. So 1 lakh multiplied by 9.46, 10 raised to the power of 15. What will this distance come out to be? 100,000. This comes out to be 9.46, 10 raised to the power of 20 meters. Let's convert it into kilometers. Divide kar do by 1000. This will come out to be 9.46, 10 raised to the power of 17 kilometer. Converted into two significant figures, 9.5, 10 raised to the power of 17 kilometers is your final answer. Easy peasy, lemon squeezy. ठीक है. हमने क्या किया बेटा? अगर आप गौर से देखो तो हमने फर्स्ट ऑफ ऑल 1 लाइट ईयर का डिस्टेंस निकाला, द डिस्टेंस फॉर 1 लाइट ईयर निकाला, द डिस्टेंस ट्रेवल्ड बाय लाइट इन 1 ईयर निकाला, द डिस्टेंस ट्रेवल्ड बाय लाइट इन 1 ईयर निकाला. कैसे निकाला? यू टुक द स्पीड ऑफ लाइट मल्टीप्लाइड बाय द टाइम इन 1 ईयर. ये आपके पास आ गया 1 लाइट ईयर का डिस्टेंस. 1000 लाइट ईयर्स किसके इक्वल होंगे? ओ सॉरी, 100,000 लाइट ईयर्स किसके इक्वल होंगे? 100,000 मल्टीप्लाइड बाय दिस. दिस इज योर 1000 light years. 100,000 light years का distance divided by 1000 to get it in kilometers. Simple answer. Astronomers determined the speed and distance from the Earth of a faraway galaxy that is moving away from Earth. State one observation that allows the speed at which a galaxy is moving away from the Earth to be determined. We have to state one observation that allows the speed at which a galaxy is moving away from the Earth to be determined. किस ऑब्जर्वेशन से हम स्पीड ऑफ द गैलेक्सी निकाल सकते हैं? द इंक्रीज इन वेवलेंथ और द अमाउंट ऑफ रेडशिफ्ट. अमाउंट ऑफ रेडशिफ्ट भी लिख देते हैं, इंक्रीज इन वेवलेंथ भी लिख देते हैं. लेट्स बी ओवर स्मार्ट. इंक्रीज इन वेवलेंथ. लेट्स फर्दर मूव अहेड. आगे बढ़ते जी. State one different observation that is used to determine the distance to a far away galaxy, the brightness of the galaxy. The brightness of the galaxy and the brightness of a supernova. Brightness of a supernova. Okay. State how the speed of the galaxy and their distances from the Earth are related. The speed of the galaxy. The speed of galaxy is directly proportional to their distances from Earth. Simple. The best estimate for Hubble space constant is this. You have to calculate the age of the universe. Age of the universe is what? 1 divided by the Hubble space constant. 1 divided by 2.2 into 10 raised to the power of minus 18. What does the age of universe comes out to be? 4.5 into 10 raised to the power of 17 seconds is your age of the universe. This marks the end of this paper. If you have any questions, you can ask me.